Scroll.com.tr'den herkese merhaba. Ben Ender Yıldız. Bugün çok özel bir röportajla karşınızdayız. AMD'nin baş oyun bilimcisi Richard Huddy bizlerle. Kendisi İstanbul'da. Welcome to Istanbul, Richard.
Thank you very much for having me here. It's a real treat to be able to sit outside on a summer's day like this in Istanbul. I'm very privileged.
It's really nice day and weather today. I'll start with my first question. VR systems are really popular these days. And what's your standpoint for a VR system as an AMD?
Okay, so absolutely VR systems are tremendously popular at the moment. I keep saying 2015 is the year of VR, and right at the end of 2015, it might be very close to the end of the year, but people will start to ship consumer units, and that's great. Yep. We've just seen an announcement from Oculus that the Rift will ship in Q1 2016, so that's a short distance behind. HTC and Valve are bringing something pretty exciting to market this year. And is it exciting? Yeah, it's actually wildly exciting. It's a fantastic opportunity for those of us in graphics, obviously, but it's a really new experience. If you haven't had the opportunity to put on one of these new lightweight, high-quality headsets and try being in a world instead of just watching it on a monitor, like when you're watching TV. When you're watching TV, typically the best kind of way of building that cinema experience of feeling like you're really there is to put the lights down, not allow any kind of visual distraction, make the world all about that sound and that audio. But a really good VR system, the kind of stuff we're seeing coming ready for market end of this year and early next, those are a fabulous way of moving yourself from thinking, okay, I'm sitting in front of a screen and I'll do what I can, to actually being in that world. It's a really, really wonderful sense of presence and immersion that is unparalleled at the moment. Now, I guess there'll be some people who don't want to wear the headset, but given how light they are these days, I think that we have a tremendous future in front of us, and it's really exciting to know that it's less than a year away.
What is the most challenging aspect of creating a realistic VR system?
So the big technical problem with VR is that when you move, and I'm watching my hands now, as I watch my hands and the muscles in my hands say, go this way, close, open, etc., everything that I get as feedback in my visual system happens almost instantly. It's within milliseconds, really, really small. In fact, it's within microseconds, but my brain does the processing a few milliseconds later, and everything is beautifully in sync. Well, computers aren't quite like that. In particular, with a VR system, you have a very low tolerance for things being out of sync. Anything over 10 or 11 milliseconds creates problems. And the most appreciable problem that you can bump into is when you get above that 11 milliseconds into 12 or 13 milliseconds. Normally, that's great in a game. If you've got a response frame like that, frame rate like that, things are fine. You get into a VR system, you get motion sickness. You feel seasick just because you turn your head. And that's not going to be acceptable to consumers. Now, the great thing about the last 2 years, when people have been looking at VR system and building towards it, they've absolutely tackled those problems. We have really high quality displays in the latest headset units. We have terrific software which is delivering very, very low latency. Of that kind of 10 and sub 10 millisecond timing, and it's taken a lot of work through the industry, not just the headset vendors, but we at AMD have brought out the Liquid VR API. It's a set of programming interfaces that let programmers really shave every millisecond out of that 10 that they want, and if they want to deliver a blissful experience, then we've got the tech ready for them now. Things are good.
Let's move on to the APIs. Why everyone waited for Mantle to fix the CPU overhead?
Well, to be fair to all the other players in the industry, they didn't just sit around waiting for Mantle to come along. We have worked with Microsoft over many generations of DirectX, from the first version that included 3D, which was DX3, all the way through to in 2009 when DX11 arrived at the market. We've worked very hard with them on reducing the CPU overhead of each of these APIs, and in one way or another we've typically made a bit of progress. But it really did come to the situation probably about 2011 where we realized that there was still a significant amount of work that needed to be done, and with Microsoft's focus shifting somewhat, I mean, by no means off gaming, but somewhat away for dealing with things like the iPad, which had arrived and was a bit of a disruptor to their market. I fully understand why they paid a great deal of attention to that. For us, of course, graphics remains the center of our focus, and we decided that if we sat down with the right games developers, we could make some. We could probably fix the issue, and indeed we did. We spent a year or two discussing it. We committed a pretty substantial amount of engineering resource to it, and we decided that it just wasn't acceptable that a single core in your CPU was bottlenecking every single game all of the time. And that's not Microsoft's fault, that's not our fault. It's really hard to get this stuff right. You have to commit a tremendous amount of R&D effort to it. And absolutely, we'd worked, very close collaboration with Microsoft through generations. But in the end, we needed to sit down with a games developer who was one of the top in the world. We worked primarily with DICE on this, the folks who did Battlefield 3 and 4 and so on. And their commitment, along with ours, was what made the difference. They were absolutely willing to use what a guy called Johan Anderson, who's one of the best rendering architects in the world, and to commit him to a significant amount of effort with us. When you have someone of that kind of quality, you say, okay, that's an investment you won't find anywhere else.
Since DirectX 12 has low-level access right now for the hardware, do we still need Mantle or Vulkan or any other low-level APIs, since DirectX will be the most popular still?
Yeah, DX12 is very good news for the PC, and it's great news for AMD. We love the fact that DX12 is arriving with Windows 10 this year, and that it will unleash all of the potential that's been sitting there unused in PCs, whether they be desktop PCs or laptops. But curiously, it doesn't mean Mantle goes away. We have focused our attention on performance with Mantle. It was our way of addressing the performance problem that was sitting there. It's kind of the elephant in the room when we were looking at PC gaming behavior. It's the thing that needs to be addressed, and we were starting to shy away from it. So we took this problem on head on, and we believe we have solved graphics performance problems with Mantle, with Kronos and the new Vulkan API, and with DX12 from Microsoft. It's solved. So yes, you might be awfully tempted to think that Mantle's going to go away now. Mantle will die. But the single thing that proves that that's not the case is if you look at Liquid VR. That's built on Mantle. Yeah, we take the technology that we have, we take the problems that developers have, trying to maximize the efficiency of their use of that technology, and we say, okay, how can we address their problems better? How can we come up with a solution which allows them to get the answers that they want more quickly? And Liquid VR has been great for VR, and it's based on Mantle. Mantle is our innovation API. So when it comes to performance, I would love games developers to switch to DX12. No problem with that. And if they want to ship on Linux, or indeed if they want to ship on on Vulkan on PC, they can do that just fine as well, yeah. And by PC, obviously, I mean a version of Windows. So Vulkan's a great thing. But when it comes to PC gaming, where one's typically talking about a Windows environment, if a games developer comes to me and says, how do I get the best performance? I'd say, start with DX12. It's the place to be. But if the games developer comes to me and says, I have a problem that I cannot solve on any operating system, on any API I know of, this is what I want to do, and I believe the hardware should be capable, how do we do it? I will probably say, okay, let's consider Mantle. Asynchronous compute shaders, asynchronous shaders, they work by allowing multiple queues of work to go into a GPU. Now that's very similar to what we see on CPUs at the moment. We're all familiar with the fact that we have multi-core CPUs, or at least I hope we are. If you're not, you shouldn't be reading this kind of site and so on. But if you're familiar with the fact that you have multiple cores on your CPU, you'll know that those cores can work on different things at any time, and with a little bit of luck, when you have twice as many cores, you can, in principle, get twice as much work done. It's not quite as linear as that, but that's where you'd hope to be. Well, the asynchronous shaders allow you to set up two queues of work. One for something which is fairly compute heavy, and something else, the other queue, for something which is largely graphics heavy. And when I say compute and graphics, really the distinction is one should be maths heavy and one should be texture or memory heavy. Once that situation prevails, then a good quality piece of graphics hardware, and I'm delighted to say that all GCN hardware supports this capability, will take those two tasks and interleave them clock by clock so that if one would leave the GPU idle, then it switches to the other and gives it some work. And we really can switch from clock cycle to clock cycle between doing one thread of work and doing another thread of work. And when you can do that, you find that the GPU, although it was 100% busy before, when you gave it a task, it took a fixed length of time, and that's the way it was, you can actually throw more work at it and get the same, well, get all the results out in the same period of time. You can take a GPU that's 100% busy, give it some more work, and it's now more than 100% busy. That's a really remarkable capability. In our best cases, even the straightforward demos that we've been building, we're seeing gains of up to 30% in some situations. That's really, really appealing. And perhaps most importantly, this is so easy to program for. All you do is you set up the 2 queues of work and let them go. If it happened that your hardware only supports 1 queue, that's okay, you just merge the queues. That's trivial. But if you can support 2, push those 2 queues down and let the hardware arbitrate which one is to be done. You know, it'll follow the priorities, it'll follow all of the ordering rules, and this is just phenomenal. We have practical experience of seeing this work on Mantle. We have practical experience of games developers working on the current generation consoles, things like the Xbox One and the PS4, and they see benefits to it. And now it comes with DX12, it comes to Windows. So we expect to see significant situations where this will result in great gains. And it requires a really cool piece of hardware. It's very, very similar to the idea of multiple CPU cores being able to collaborate on pieces of work in a complicated way, but it requires a hardware scheduler inside the hardware, and AMD is showing leadership in this area. It's a really cool feature.
All of the GCN-based graphic cards will have this scheduler?
All of the GCN-based graphics cards, and indeed all of our GCN-based APUs. So you can imagine a situation where I start boasting about the fact that our high-end GPU, which is running some exciting game at 100 frames a second, now runs it at 120 or something like that. That's all very well, and that's a wonderful thing. That lets games developers use up the extra resource up there. But imagine the situation on an APU. Think about a game that's running at, say, 40 or 50 frames a second, or maybe 30 or 40 frames a second, and it's saturating its GPU. And now you can throw more work at it on that laptop, and it just gets through the same amount of time, but a larger amount of work. The quality of games just goes up, and to be able to show that that's a benefit on APUs, that's a wonderful place for us to be.
But I believe most of the time APU is memory limited, not GPU limited, because the DDR3 memory is really low on bandwidth side. Maybe HBM or DDR4 will fix that. But for now, do you think it's more memory limited or GPU limited?
Yeah, so if a task is memory limited, and you're quite right that the APU and the discrete GPU have different kind of characteristics. If you go to an APU and you find it so it's totally memory limited, if every single piece of work that it's doing is memory limited, then asynchronous shaders will not help. But that's a tremendously rare situation. One of the examples that I came across when I was talking to a games developer at GDC about this, he said, he's doing a lot of rendering. He's doing stuff which is basically memory bound, so the kind of thing that would be limited on an APU at the moment. And asynchronously, in his compute shader, he runs visibility tests. Now these are trivial, really small bits of compute work which are totally the opposite. Yeah, they are not memory limited, they are compute limited. And the cool thing is, if you get the result back from this quickly enough, then it tells you don't need to draw something that would have been slightly later in the pipeline. You can cull it from the pipeline, and you can use a little bit of compute horsepower to save the bandwidth at the back end. So you can magnify. It works like a magnifying glass where you have a modest amount of compute work there, and it can save you a substantial amount of memory bandwidth work, and therefore impact the frame rate substantially too. You're right that the balance is different, and that APUs are much more often memory limited, but you can actually use the compute capability here to protect memory bandwidth, which is great.
Let's move on to FreeSync. We know FreeSync is a free technology, but cost of scaler chip is same with the ones without FreeSync support, and the monitor manufacturers will charge for extra because, you know, my monitor is now supporting FreeSync.
Well, if I were a monitor manufacturer, I would like to do that, but there is pressure against them for doing that. Yeah, the truth is that FreeSync, which arrives here in Turkey in 2 weeks' time or so, and we're dating this from what, May the 14th? Where are we? I forget exactly the date now. But in 2 weeks' time, you will have availability of the first FreeSync monitors. And I could understand if that vendor, and I believe it's going to be BenQ, wanted to charge some small premium for it. But the truth is, you're quite right, the scalers are no more expensive than they used to be beforehand. There is no license fee that comes from AMD or the other authorities, the Visa Standards Authority that controls this stuff. So there isn't actually anything that needs to add to the cost. It's fair enough to charge a little bit more for something which is new. And, you know, if BenQ wanted to, they could add $1 million to it. They're not going to. My understanding is that the monitor manufacturers actually understand this is the way capitalism works. And you know, deep down at heart, I'm a bit of a socialist, but capitalism is a fabulous solution for this. When you have competition, and we've seen ViewSonic, BenQ, Samsung, Asus, LG, numerous manufacturers coming to market, what they want to do is get to market first, and they want to get there and set standards with quality and things like that, rather than trying to push prices up. So I expect there will be no price premium of any significance for FreeSync.
There's a common belief that consoles, especially PlayStation 3 and Xbox 360, are dragging down the PC gaming. Do you agree on this?
Yeah, it's an interesting question, and I suppose it's fair to say that there is a common perception about that. The truth is that both the Xbox 360 and the PlayStation 3 are pretty heavily outclassed nowadays by modern PC hardware, and indeed they're outclassed by their younger brothers, the Xbox One and the PlayStation 4. So if I were buying a console, I'd buy one of those newer consoles right at the moment. That seems to me the obvious place to choose. But I fully understand that there are a lot of people, tens of millions of people, who own PlayStation 3s or Xbox 360s. And it won't surprise you to say that to hear that Xbox 360 was my choice. That's the one with the AMD GPU in it. But if you have that and you invested the money in it, why shouldn't you get the games? If the publisher can satisfy your needs as a publisher of games, why shouldn't they bring the games to those platforms? And I'm positive, I'm pleased about the fact that both Microsoft and Sony have chosen to keep their old consoles in the market. It's okay. It's a perfectly reasonable thing to do. Now, that does mean that there's a larger spread now between the lowest end and the highest end. But to be really brutally honest, there's always been a very large spread between low-end PC and high-end PC. You could argue that we should stop selling all that low-end stuff because it holds people back. But, you know, people choose what they want to buy, and that's the good side of capitalism.
I believe moving on to PC-based consoles, PC-based hardware console will fix it, because, you know, when you want to make a new console, like let's say like PlayStation 5, you can just put a new GCN chip on it and have backwards compatibility, and game developers can have two different versions of the game easily, because, you know, you can keep the low specs for the PlayStation 4 and have the higher settings for the PlayStation 5.
Well, you could go down this route, but if you go too far down it, then you end up with exactly the problem that we have in PCs. The console delivers a different kind of experience. The console is intended to be used at 3 meters or so user distance, but fundamentally it's an experience that always works. You put your game in, it runs, there is never a problem. You never have to go through the pain of installing drivers. And even I sometimes struggle with installing drivers. There are technical aspects to a PC which are in some respects superior, but there are user aspects which are not the same. And if you want it, you get it from a console. If you want that ease of use. And if you have a PlayStation 5 that's upgraded by just adding an extra GPU, and then you have a PlayStation 5.1 where someone put in a little bit more memory, and then a 5.2 where they put in some more memory but not quite as much, well, you're ending up with a PC. So I think that the kind of discrete nature of the generations of consoles makes very good sense to me. If I want to target a console, I know exactly what it is. And for console holders, that's an astonishingly high priority. Whenever they come to us about revising the silicon, they would come to us, the proviso would be, when you make the change, it has to run clock for clock exactly as it did before, even if you're moving to a new process or something like that. And that's a pretty tough ask, actually. That can be very hard, but it's the only way to stop it gravitating towards that fragmented PC. And there's great news in fragmented PCs. There's tremendous component competition. It's a wonderful place to play. But, you know, you choose. You pays your money, you takes your choice.
Thank you, Richard. Thank you for your time.
A great pleasure. Thank you very much for having me on, and again, for this beautiful Istanbul day that you arranged for me. I'm grateful to be here.
The pleasure is all mine.